welcome to another video of Sigma Sciences. So today we'll be looking at algebraic equations, and this is in fact my first mathematics video that I've published. So thanks to lots of recommendations to do this, today we're going to look at this specific topic on math. Okay, so today we're going to look at solving one-step algebraic equations. And don't get scared by, that name or variables, because it's really easy once you get the hang of it. Okay, first thing we need to do is identify the expression. We know an algebraic expression or equation is a one step, like solving one step, because there's only one thing happening to the variable. Okay, what's the variable? The variable is the letter X, Y, H, another X, X, and X. It's our unknown. So, how do we know one-step equations? What do they mean? It's when only one thing is happening to our variable. What would that be like? For example, X, let me just pick that. X minus 9 is a one-step equation because only one thing is happening to X, and that's it's being subtracted by 9. But this one wouldn't, because X is being multiplied by 2 and additionally divided by 3. So that wouldn't be a one-step equation, but it would be a two-step equation. Now, they're really just the same, just that they have more steps. But today we'll only look at one-step equations, and it's important to know what you're solving, basically. So this one's a one-step, this one isn't. Now this one is a one-step too, because X is only being multiplied by 18. This one wouldn't, because 5y plus 45 is, multiplying by 5 and then adding 45. So that wouldn't be one step. H plus 19 would, because we're only adding to H, only one thing. And 7x also could, because we're multiplying 7 to x. Okay, step 2, coefficient or constant. Here, what can we see? This is our variable, and our coefficient is the thing that accompanies the number, that variable. It's basically like saying x equals cookies. Well, we multiply that number of cookies by 18 to give us 288. I hope that wasn't so confusing. And, that's a coefficient, and it will always multiply. Then there's a constant, and it's what, is happening to the x. Of course, this can be what's right there next to it, but it's what could happen, like division. Multiplication could be possible, but it's more seen in this form. So division, multiplication, subtraction, and addition. So for example, here we have an unknown number of cookies, and if we take away 9, we have 49. So what is that number of cookies? Here you can see I already did it. So 18x equals 288. What we have to do here is, what is 18 doing to x? Well, it's multiplying it, isn't it? So we have to do the inverse. We write it down here, 18x over 18, which means division. Here it's really easy because we cancel out the 18s, leaving us with x. X equals, and we also have to divide the other side by 18 too. If we do all this procedure, we'll see x, because x is alone here, the equal sign, and the answer, which in this case is 16. Here we have x minus 9 equal 49. What's 9 doing to x? It's subtracting. So we have to add. That way we can cancel the 9s, leaving us with x, plus 9 on the other side will leave us with x equals 58. Now you may wonder, well, yeah, this is incredible and all, but how do we know it's right? For example, if we add something, we would subtract it in an equation to see if it's right. How do we do that here? Nice question. So, what can we do here is we write 18 for this example, and then we substitute x with the actual value we believe it is, equals 288. Okay. After we multiply 18 by 16, well, I've already done that. You can go ahead and do it. I'll give you a few seconds. You can always pause the video. Okay, I guess that would be good. Now, this actually does give us 288. And do you guys think 288 is the same as 288? Well, spoiler alert, it is. So that's the way we check. Also, let me do it with the other example. Let me erase that. And then we substitute the value 58 minus 9 equals 49. And then you can simply, well, do it. I'll give you some time, but I've done this before, so I won't do the procedure this time. Okay, so the answer would be 49. 49 is the same as 49, isn't it? So that's the way we check. Let's keep on going. Okay, let's do some example questions. X plus 29 equals 86. Now remember, plus, what is the inverse of plus? Subtraction. And we always have to do it on both sides. So I'll give you a few seconds to do that, and you can always pause the video. Okay, there we go. Now, here's our procedure. We have x plus 29 equals 86. We subtract 29 here and 29 here. We cancel the 29s, leaving us with our x, and x would equal 57. If you also got that, well done. Let's try another one. Whoops. Okay. 12y equals 148. Of course, here I already wrote the procedure, so you can go ahead and look at that. So, 12y equals 148. Well, we divide 12 because here's multiplying. We're left with y, and we do the same on the other side. Now remember, these equations are not always whole numbers. They can be decimals too. And also, you do not need to add the infinity of decimals. You just need to add 2 to be valid. This would leave us with y equals 12.33. So, after this, I'll link some questions below so you can practice on that. I guess you've done well on part 1 of step 3, so our other example question. And this one was just kind of to refresh. Now, I'll see you soon. Thank you for watching, and I hope you guys enjoyed. Bye!